Welcome again to another session. We have a problem on board. This is a past question was I informed on electricity. And let's look at the question and see how best we can solve it together. The first thing here is we are saying the resistance of a voltmeter in the circuit diagram illustrated above is 800 ohms. This one is ohms, then this one is a calculated voltmeter reading. That means you are asked to find the voltmeter reading. Mind you, in this case, you are not asked to find just the current, you are asked to find the voltmeter reading. So before we solve this, let's understand one thing in solving problem on electricity. First of all, when you look at this particular whole diagram you see here, is what's called a circuit, right? Then again, what we need to understand about the circuit, we have what we call cells. In the solve of electricity, we have what we call cells, we have what we call resistance or resistors. When we say cells, when we say resistance, they are in different form. That means, example, if we are going to be looking at this particular one here, you are seeing something V here. This V represents voltmeter, and it is there to record the amount of current that flow through this particular circuit. Then again, when you look at this particular thing here, these are what we call resistors. This one is called resistors. I will say resistor 1, resistor 2, anyhow, right? But these are called resistors. So they are connected. Most times, resistors or neither cells are connected. It's either in series or parallel. When we come to in regards to this particular area of electricity, for the parallel connection, they have their own formula. For the series connection, they have also their formula. Then for the series connection, we are saying is an end-to-end connection. That means if I'm having a resistor here, another resistor here, if they connect like this, this one is end because this part is the end part, this also is the end part. So it's end-to-end connection. So this will call to be a series connection. And if you're asked to find the total resistance of these cells, we are just going to add this and this together. That's done. When we come to parallel connection, this one is like side-by-side connection. That means they are going to be connected like this, side by side. So because of that, we call it a parallel connection, right? In that regards, if you are asked to find the total resistance for this, we are going to be using what we call the inverse. And the inverse simply means 1 all over that particular thing. When we say inverse, it's 1 upon that particular thing. So in that regard, if we are going to be looking at this, in a nutshell, we are asked to find the volts reading, right? So first of all, whenever you are solving problem for this, always try to understand that this problem or these particular resistors are connected here in what? Parallel. And this one here is also connected to this in what? Series, because it's end to end. So first of all, always if you are solving problems, you can start from here. But always choose the parallel connection. From there, you combine it with what? This particular connection we have here. That means the series connection. You start with the parallel and you go to the series. So let's see how best we can solve this. We say solution, right? And from there, from solution, what you need to know about electricity, the most important thing, we have what's called the Ohm's law. When we say Ohm's law, it is a law that states we are saying the current that passing through a metallic conductor is directly proportional to the potential difference, provided the temperature is the temperature is constant. So in that regard, if I'm going to be looking at this particular point, that means by expression we are saying V is equal to IR. But based on what I said, we are saying the current. That means I here represents current. We are saying current is proportional to this potential difference represents V here. But in that regard, I'm using this one here. I'm going to be using what we call V equal to, I will add the constant, and the constant is we're supposed to have R, I here, right? This is what we're supposed to be having. That means if we express it into mathematics. So if we say V proportional to this particular I, that means if I change this one to mathematics, I will have R and this. But this R is the same as equal to I. That's why we bring the I here. That means we have I equal to what? I all over and something like this. So this is what we have for the Ohm's law. So we use this to solve problems under this particular area of electricity. Very important. So let's see how best we can solve this problem together. Now, first of all, let's consider, for my initial statement, I said you should consider the parallel connection. So if that be the case, for the parallel connection, we have 4 here, we have 400 here, 400 ohms, 400 ohms. So if that be the case, for the parallel connection, I will take this one to be R1. This total here to be R1. So I will just say I have R1 here equal to, for parallel connection, we'll take the inverse. If you are saying the inverse, that means you are going to have 1 all over R1 plus 1 all over R2. So in that regards, I'll bring values. That means this R1 here equal to, R1 simply means this total, because we have another resistor here. So in that regards, I'll have 1 all over R1 now becomes this 400. So I will have 1 all over 400 here plus 1 all over 400 again we have, right? So this is what we have. Whenever I ask to find the total resistance, because always if you are solving for, you need to find the total resistance. And the total resistance, whenever you ask to find it or you are about to find it, try at least to use the inverse as long as it's a parallel connection. So in that regards, in this case, I will decide to say, okay, now these are having the same denominators are the same. In mathematics, when the denominators are the same, we take 1. So if that be the case, let us see what we have here. So it means I will have R1 here equal to 400 as LCM all over 400 divided by this is just the same thing I have, right? So I'll add this particular number because I use one denominator because they are the same. In mathematics, if they are the same, you take 1. So I take 1 here, they add the numerators. That means I have 1 all over 1 plus what? 1. Because 1 plus 1 here is what I have. So if I express this now, I will have R1 equal to, what do I have? 1 all over this one is going to give me 2 all over 400. And 2 all over 400 here, 2 into itself is just 1. So now in this case, what we have here, right? What we have for this, because the formula says, I'm saying you are going to use the inverse. That means 1 all over R here is just what we have. So in that case, this particular formula I want to have, I'm going to have 1 all over R, right? So since I have this all over this, it's the same thing again that I have 1 all over R here, right? As the formula. Let me just replace this one. Let me just replace this. That means I have 1 all over R like this, right? So this is what I have. So if I have an inverse and I have another fraction here, I will decide to remove this inverse. If I want to remove this inverse, that means I will have R all over what? 1. And equal to this, I will invert it. That means I will have 400 all over what? 2. So in this case, 1 divided by anything divided by 1 is that particular value of that thing, right? So this R divided by 1 is the same as what? R. So R now become equal to, that means the R1 for this become equal to 2 into itself is 1, 2 here is what? 2 here is 2 and 200. So I have 200 here, right? 200 ohms. So this is what I have for the first resistance for this connection here. Then here in this case, they are connected in series. Don't be tempted to just add this and this together, because when you see series connection, you add them together, right? But don't be tempted to add this together, because if you look at the problem here, we are saying the circuit diagram illustrates above is 800, right, ohms. That means this particular here, we are having 800 again here for this particular voltmeter here. They are in what? Parallel connection. That means this voltmeter is 800. So if this one be 800, that means they are in what? Parallel connection. So I will also use a parallel connection again to like solve for this parallel connection. From there, I will take them and add them together. So let's say for R2, I will take this to be what? R2. That means I'll have 1 all over R2. So this is what I have. All equal to, I will use the same formula again. The formula says what? 1 all over R1 here plus 1 all over R2. So now in this case, what I have now is going to be what? Let me just solve it from this part. Now what I have from this point, I will have 1 all over R here equal to, this now bring values, that means 1 all over, what I have for this is 800. And the voltmeter reading also is what? 800 from the problem, right? We have, because we are saying illustrated above is what? 400 ohms. That means this one is 400 ohms. So that means I have plus 800 as well, right? So if I have this now, I will still take 1 all over R here, all equal to, I'm having the same denominators. I will take 1, right, as LCM. They will add what? These particular numerators. If I add them together, I will have 1 all over what? This one here, all equal to 2 all over what? 800. So in this regard, if I have this, I will decide to like what? Say, I will invert this to have a single area, because this one is in inverse, right? So since I have an inverse, I will decide to like change this particular inverse because I want to find R, just the value of R. So I will decide to remove this inverse. If I want to remove it, I will invert it. That means I'll have R all over 1 here, right? I'll have R all over 1 all equal to, I'll invert this as well. Then that means I'll have 800 here all over 2. Then in this case, 1 divided, or anything divided by 1 is the same as that particular value. That means I will still have what? R equal to 2 into itself 1, 2 here is 400. So that means I have 400 ohm for the R2, right? Now R2 here, this one is 400 and this also is what? 200. So they are connected in what? Series. So now for the series connection, always there are to add them up together. So that means for me to have the total resistance, I'll call it total resistance. I'm going to have what? R1 plus what? R2. And R1 now become now total resistance become R1 become the value that I get from this point, right? This is what to call this is what to have for R1. That means I'll have 200 ohms plus R2 now becomes what? 400. That means I'll have 400 again, right? If I put them together, this is going to be the total resistance. That means 6. This plus this is going to give me, this plus this is 6. 200 plus 400 gives me 600. So that means total resistance is going to be 600. If we are asked to find the total resistance here, I'm done with this problem. But we are not asked to find the total resistance. I'm asked to find the voltmeter reading. So if I may continue, that means if I have this from this particular point, from Ohm's law here, we are saying V equal to IR, right? I'm having V equal to IR. So it means I need to know the reading. That means the current that passed through this particular circuit. If I'm to know this particular current that passed through this circuit, that means in that regards, I will have this as a subject. I will divide both side by this cancel, then I will have R equal to V all over. This R represents total resistance. So if that be the case, I'll bring the same formula here to find the value of I. I equal to V all over R, which is the total resistance. So V all over R now becomes what? I will have now I equal to V now becomes the reading. That means we are referring to the EMF, or maybe the amount of current that is that means, like, let's just say the power, right? The power that is moving, or that this particular circuit is having, right? So if that be the case, the power here is what? 6 volts, right? So the power that is moving that they are supplying inside this particular circuit is 6 volts. So that means this one represents this one here. That means I'm going to have what? 6 all over. This one represents total resistance. This is the total resistance for the entire circuit. That means I'll have 600. So if I have 600, that means I'll have I equal to this divided by this is something like 1. That means 0.01, right? And this one is current, and current is measured in ampere. So this is what I have. So the next thing is because we are not just asked to find the current, we are asked to find the voltmeter reading, right? That means the reading of the voltmeter. Then always for the reading of what? Let me just say reading of voltmeter, right? For the reading of voltmeter is equal to or proportional to the potential difference across the circuit. Why? Because for the potential difference, it is saying when we have a potential difference, it simply means it is a current that flows through in a closed circuit. Whereas we also have what's called an EMF, right? EMF simply means electromotive force. And that one there, it is in what? In a closed, in an open circuit. That means in the sense, if you are performing a practical in regards to this area, we have what's called a key. And that particular key, when they close the key, the current is going to move within the circuit. When you open it, there is no current that's going to pass through, right? That's why in performing this is one of the precautions we have under the practical for this electricity. Where if you are not measuring any current, or if you are not measuring anything, you need to, like, how can I say it? You need to, like, remove the key, right, from that particular street. So that means in that regard, so if the current is passing through, the voltmeter is going to be reading, right, or the potential difference is going to be reading. So they are equivalent, that they are the same. So in that regard, that means if that be the case, the potential difference we have here from Ohm's law, we are saying V is equal to IR. R is the resistance, this one is current, and this one is the potential difference. So if that be the case, this one is the potential difference. I'm going to be using this formula to be solving for this. And this one we are saying potential difference equal to this. So therefore, I'm going to multiply. That means this V here is going to be equal to IR. And the IR here is what? The I is what? This particular point we have. That means 0.01 times the resistance is not just all the resistance, but the problem we are seeing illustrated above is what? 800. So we are going to check for the resistance for the 800 ohms. It's not the entire resistance we are going to be using, right? So the resistance we have for this 800 ohms here, or this particular 800 reading for that particular volt here, is 400 for what we solved from initial thing we solved here. That means it's 400. So I'll take that 400. That means I'll have this times what? 400. And if I multiply this times 400, it's going to give me something like this times this not. Okay, it's going to give me something like 0.4. Okay, it's going to give me 4. That means, therefore, the voltmeter reading is equal to 4. And this one is the same thing we call measuring what? Volt, right? That means the potential difference is measured in volts. Then this is voltmeter reading is just what? V. So that means if I'm asked to solve this problem, this